Let's make some noise! Our next two teams are about to start. On the A side, on the left of your screen, it's the University of Utah. On the B side, on the right of your screen, we have the University of Central Florida. And we are underway. The first competition for both of these teams has started.
Now, this one looks like a very different kind of a bucket from what we've seen here today.
Yes, this is a front bucket system, which is basically like a lot of the caterpillar digging equipment that you'll see here on Earth. The difference is that in this competition, these robots need to be very lightweight, so they need to figure out a way to dig using a very lightweight robot versus a very heavy excavator like you often see out there in the world. Both of these robots in motion, and the Utah robot has a bucket full and looks like it's heading back. You can see that the students on the Utah side have placed some barcodes on the lander, and those barcodes are commonly used by teams to help the robot decide where it is in the arena. Oh, there's a big crater right there.
Made it through, though.
Made it through. So it has to lift up the bucket high enough.
That's quite an arm on that thing.
Yeah. These teams have to be careful to design their robots such that they can hold, that they won't tip over when they're fully loaded, and that they also have the reach that they can extend over to deposit their Regulus simulant into the lander's hopper. On the right, DF robot is coming across the obstacle field. You can see they've made it. UCF has made it over to the digging area. And you can see the green wheels on the UCF robot. Those are actually 3D printed plastic wheels, which is a very innovative way to create parts for your robot, is just to design them into a 3D CAD and use a 3D printer. You can see UCF excavating right there with a bucket ladder system and depositing the regular.
Speaking of 3D printing, use regolith like that to 3D print.
That's one of the ideas that NASA is using right now for in-situ resource utilization, or living off the 3D print structures on using the regolith as feedstock. So this is pretty interesting technology that NASA's working on right now. And the UCF robot, a big difference between these two robots' design is that it digs and it transports and it dumps using one system, a front-mounted bucket on an arm. And that seems to be working for them, because right now they have over 10 kilograms in their deposited into the hopper on the Utah side. Oh, and it's a little front heavy when it's full of the Regulus simulant, so they're going to have to be careful there. But on the UCF side, you can see they've got a digging system, and then they have an area in the center of the robot that's actually used to hold onto the regolith, and then this system that holds onto the regolith actually lifts up like a dump truck bed, and it actually deposits the regolith simulant out the back side of the robot. So you can see it trying to turn around because it has to back up the lander's hopper. Meanwhile, Utah has dumped another load, and we'll wait for the scale to settle down. It looks like it's close to 19 kilograms on the Utah side. Very respectable score for this team. Now, they have a lot of regolith on board, so they just have to get the rope position back to the lander and get that deposited. Hopefully the UCF robot has enough ground clearance with those wheels in order to get across that obstacle field and not get stuck when the robot's weighed down with all that Regulus simulant. This stuff is actually pretty heavy. It's very fine crushed volcanic rock, and it can actually weigh quite a bit when you get a lot of it on board. This is actually a reverse angle. This is a camera view that the students can actually see in the control room. The students in the camera views in the control room, both of them from the perspective of the lander. So that view we just saw was the perspective, an overhead view from the lander looking out at the regular arena. And then we also provide them a side view of the screen right now. Only those two camera views. Oh, UCF, there's a hole right there. Only those two camera views are available to the students unless they have an onboard camera that they've designed into their robot. Utah going back for another load, and they have them so far with 4 minutes remaining in this match. With 4 minutes remaining, UCF still has a chance to get out of that hole and deposit the load that they have on board.
Looks like it's almost there. She can do it. She can do it.
I've noticed that these robots really respond. Give robots some love. So the students in the control room are monitoring the situation, looking at their data, looking at views. There goes Utah, a little front heavy there. They're looking at their camera views and their data to see if there's anything they can do to try and get out of that hole.
Very interesting, Kurt, how the University of Utah is using its bucket.
Yes, that is with a bucket on an arm like that. It's a blessing at times. It can actually be used to get yourself unstuck. And the UCF robot has backed out of their crater. And with only with 3 minutes left, the UC, I think they'll have time if they can get across that obstacle field without falling into a crater or getting stuck on a rock. Their robot might be a little heavy right now, though. See if they can get out of there. With 2.5 minutes left, both of these teams have an exciting run right now. Almost 40 kilograms. It'll be able to get one more run in at least, what I've seen. And the UCF robot, let's see if they can get their robot back to the hopper and unload. Because honestly, it looks like they've got a lot of regular simulant on board, that UCF robot. It looks like they were able to excavate quite a bit of that crushed volcano.
Now, Kurt, if their robot is too heavy because of that regolith, do they have the option?
Yes, if they decide their strategy, they could lighten up their robot by dumping some of it off board and then lightening up the robot. Of course, if they're already bottomed out, if they've already lost all their ground clearance, help them. So they've got all these decisions to make in the control room. Here comes Utah with 1.5 minutes, coming back with another load. You'll notice they've tipped over a few times, so they're trying to keep their bucket low as they traverse the obstacle field now. That looked like a really hefty bucket load right there. That looked like a lot of regolith on that run. And with 1:10 minutes, let's see if Utah can get one. Utah's scale, I'm waiting for the scale to settle down. Utah's scale is at almost, well, it's, okay, let's call it almost 52 kilograms. Okay, 50 seconds remains. Sarah, you were just talking about UCF maybe offloading that weight.
There
Looks
it goes.
like they might be trying that. With only 50 seconds, with only 40 seconds left, it might be a little late for that. But let's see what they can get done. At least let's see how much comes out, because that'll tell us how much they were able to dig. Yeah, that was respectable right there.
Amount, yeah.
That was respectable. I would consider that a really great effort for the UCF team. Analyze what happened offline and come back can get a really strong second attempt in later on in this week. And here comes Utah with only 7, 6, 5, 4, 3. That's it. They were able, now wait for the scale to settle down, at more than 50 kilograms. Way to go, Utah. And to both of these teams, University of Utah and University of Central Florida. Very good job, both of these teams. And they're going to get it. Both of these teams are going to get a chance to come back later on this week and put in a second attempt and increase their score in this competition. While you're here at the Kennedy Space Center Visitor Complex, make sure you go enjoy the Visitor Center. Go see Atlantis. Go see some IMAX movies during your downtime. Make sure you do that while you're here. A lot of really great sponsors that help us put on this competition. We would not be able to put on a competition like this at this magnitude. This takes a lot of work. It actually takes a lot of money to set up this competition. So these sponsors, we would do this without. Our biggest and awesome sponsor is Caterpillar Incorporated. Let's give Caterpillar a big hand. Competition without Caterpillar. You're going to see Caterpillar employees walking around. They're actually, talking to students and, learning about the students and taking. So, if you see a Caterpillar employee with the Caterpillar shirts, and talk to him about your robot. We also have other sponsors that help us put on this event. We have the Boeing Company, the Harris Corporation, Moon Express Incorporated. Also helping us out is Honeybee Robotics, Space Florida, the Visitor Complex, obviously, Seacourse Strategies, and Atlantis Education. And helping us out with all our audio and visual needs is a thank you to all of our sponsors. Please make sure you turn off Wi-Fi hotspots. We don't